Here we go. So what do we got here? What's the answer? How many, exactly how many intercepts does it have? 3 is correct. Maisie, how come? Everybody listen please, folks up here.
Because there's 3 x's.
Because there's 3 distinct factors. Good. Each of those factors gives us an x-intercept. Very good. Okay, how about this part? Now, this is going to be easier to do after tomorrow. Tomorrow we're going to talk about multiplying polynomials. For now, it's not hard. You already could do this. If I were to expand all this out, all you got to think about is what's going to be the biggest power of x, because that's going to give us the degree of the polynomial, right? So let's see, if I multiply the first 2 together, what's the biggest power of x going to be? X squared. If I multiply that result by the third one, what's that going to make the biggest power of x? Cubed, right? I'm going to get x to the 1 times x to the 1 is x squared times x to the 1 is x cubed. That's all we care about. We don't need to know if it's positive or negative or any of that stuff. Just what's the biggest power. So if the degree is 3, then any polynomial that has a degree of 3 could have at the very most how many turning points? 2. 1 less than that, right? Okay, so the answers would just be 3 and 2. Okay, how about this one? How many x-intercepts does that have? 4. Okay, what's the degree of that one going to be?
3.
The degree.
Oh, the degree. That'd be.
I'm going to multiply x times x times x times x. X to the 4th, right? So the degree is 4. The question wants to know how many turning points could it have at most then? 3. So it would be 4 and 3 would be the answers. Okay, one more. How about this one? How many x-intercepts? 2. Good, because there's 2 distinct factors. Okay, but now, what's the degree going to be this time? 3. Good, because I'm going to have an x squared, right? Because I'm really multiplying that by itself. So an x squared times an x is x cubed. So at most, how many turning points?
2.
No, 2. So 2 and 2, right? Okay, we're good. All right, how about this? I want to make sure we understand what this terminology is all about. It's really simple. This is on the new assignment, the 6.1 assignment. So this is a polynomial, but it's not written in standard form. How come? What do I have to do to put it into standard form? If there were like terms, I would combine them. Now there aren't any. So, but if we needed to, we'd have to do that. You're right. But once I've done that, once I've combined like terms, which evidently has already been done, it's still not in standard form. What do I do?
Put it in order.
Okay, which order?
Just gonna go from the greatest exponent to the smallest.
Perfect. Goes from the biggest exponent to the least. So the first term would need to be that one, right? Because that's got an x to the 5th. So it would be 2x to the 5th plus 4x cubed minus 6x squared minus 11x plus 9. All I have to do is put them in order, right?
Yeah, right.
So then what's the degree of the polynomial? You want me to write it down? Okay. Okay, the degree is what?
What is
5. How come? Biggest power of x. That's it. Okay, so what's the leading coefficient?
5.
No. What's a coefficient?
It'd be 2.
2. It'd be 2 because it's whatever the coefficient is in the leading or first term.
So if it's just x5, it would just be 1.
Yeah. It was just x to the 5th, yeah. Okay, no biggie. You got it. Okay, so let's come down here to these. Okay, so this is really simple stuff. Now, all we're doing here with this assignment is about adding and subtracting polynomials. It is the easiest assignment you'll have for the rest of the year, so enjoy it. I mean, it could not get easier. All we're doing here is when you add polynomials, what? What are you doing? Combining like terms. That's it. That's all you're doing is combining like terms. So if I've got something, I don't want to spend a lot of time on this because it's so simple. Okay, so one thing, if I'm adding polynomials, do those parentheses even do anything? They don't. They don't do anything because look what number is out in front of each. There's a 1. Multiplying 1, distributing a 1 through doesn't change anything, right? Keeps it exactly the same. So I could just think of those as being gone. I don't even need them there. All I'm doing then when I add these up is literally just combining like terms. So for example, what's the biggest power of x here? Looks like x to the 4th. So now think about this though. Just be careful with this. What is negative 7x to the 4th plus 4x to the 4th?
Negative 3.
Negative 3
X 4 8.
x to the, is it the 8th or the 4th? Let me ask you this. If I add up, if I've got 3 apples and I add 5 apples, what do I get?
You get 8.
I get 8 apples, not oranges, right?
Yeah.
So if I have negative 7 apples plus 4 apples, I'm going to get negative 3 apples. You see my point? All these coefficients they're just telling us the numbers of those terms that we have. I have negative 7 of those x to the 4ths here, and I have 4 of them here. So the total number I have is negative 3 of those x to the 4ths, right? We don't change the exponents there. We're just adding up numbers of things. So we're going to get negative 3 x to the 4th, and I'll cross those out and get rid of them. We're done with those. What about x cubes?
You get 6 to the x cubed.
Okay, I'm going to get 2 of those plus 4 of those is 6 of those.
And then you get x squared.
And yeah, I get negative 5 of those plus 6 gives us just 1 of those, right? 1x squared. And then there's only negative 1x is total.
And then you have negative 14.
And then negative 14. And we took care of all of them. Easy, right? No big deal. Okay, how about okay, I'm going to show you a little trick on this one. Okay, now notice these are all just being added though, right? So I don't even need the parentheses. Okay, here's what you can do with this though. We can add these vertically. This is a good way to do it. If I add them vertically, here's what that means is I'm just going to leave a column for each of the powers of x, starting with the biggest power of x that shows up anywhere, which is what? X to the 4th. Okay, so I'm going to need an x to the 4th row or column right here. I'm going to need an x cubed column and an x squared and an x and a constant all the way down. And I've got to keep those columns intact. Even though, like for example, this first polynomial, which I'm going to make the blue one, only has 3 terms and we're missing quite a few, I still have to stick with those columns in case the other polynomials do have pieces that I need to add in the other columns, right? So the first one would just look like negative 6 x to the 4th, skip x cubed, skip x squared, minus 10x minus 5. And then we're adding to that this guy. Well, this one will be red. What columns do those go in? So I've got a plus 7 x to the 4th. Skip the x cubed. I've got an x squared though, a minus 7 x squared, and then a plus 7, right? Okay, this one will be green, how about? So now I've got, I'm going to subtract, I'm going to add a negative 5x to the 4th, same as subtracting it. I've got a plus 3x cubed minus 10x squared minus 10x plus 1. And now all I've got to do is add vertically, right? How many x to the 4th do I have? Well, negative 6 plus 7 is 1, minus 5 is what? Negative 4. So I've got negative 4 of those. I've got 3 of those. That's easy.
Negative 17 is
Negative 17 of those. Negative 20 of those. And what?
3.
3. Plus 3. That's it. Okay? No big deal, right? That's something that maybe is more useful if you're doing a whole bunch of them. If you're adding up a whole bunch of polynomials at once, then that might be a good way to do it. Right. Otherwise, it'd be pretty hard to do if you were adding them all up horizontally. That's a lot of things to cross off as you go, right? Okay, how about we'll do one more, and then I think I'm going to turn you loose. Let's do, how about this? Okay, we're subtracting this time. How are we gonna do that? What do you think? I could subtract term by term, but I don't recommend that. Good. We're gonna distribute the negative sign and add, right? Does that make sense? So what's the coefficient here? Well, there is no coefficient. I don't even really need to, I can get rid of the parentheses for this one. Nothing changes there, right? So the first polynomial stays the same. Negative 4x to the fourth plus 5x cubed plus 3x squared minus 6x minus 8. But I'm subtracting this one, so I'm going to have to distribute that negative 1 all the way through. But what's it going to do if I distribute a negative 1 all the way through? What do you think? Justine, what's that going to do? If I distribute a negative 1 to each of those terms, what's it going to do to each term? Well, like, what's the first one going to become if I distribute a negative 1?
Negative 10x.
What's the next one going to become?
Negative 8.
Okay, well, what's that doing? It seems like it's just changing the signs, right? So last one would be plus 6. Okay, so all I'm doing is just switching the signs on the last one, and now I just add them up, like what we did before. Okay, no big deal. There are a couple other problems, but I'm going to let you guys, I'm not going to help you with these. The other ones, you're going to have to just think about these a little bit. I gave you a couple word problems that involve like a rectangle. Now, maybe we'll go through one of these real quick. That's all I want to do, is just one. So what if we take this guy, real quick here. This one, we've got, so if that's my, I guess I made it a square. Pretend it's a rectangle. Square is a rectangle. Okay, what's this telling us here? It tells us a rectangle has a length of x, and so we'll call this the length, I guess, right? So that's x, and a width, I guess we'll call that the width of x cubed plus 2x squared plus 2x plus 1. They want you to come up with a polynomial, call it p of x, that represents the perimeter. So how am I going to find the perimeter of this thing? What's going to be the length of this side?
X.
That's going to be x, good. And then this one over here is going to be the same as that, right?
Yeah, and then add them all up.
I just add them up, right? If I add those up, that's going to give me the perimeter, collect like terms. No big deal.
So if you combine those x's, that'd be x squared, right?
No, wouldn't be x. What do you mean?
Well,
Like these
the
two?
Yeah.
No, because I'm adding them. Or I could even just multiply by 2. I could even just do this, right? I could say, okay, whatever that one is, I'm going to multiply that by 2 because there's going to be two sides with the same
Okay.
dimension. Multiply that one by 2. If I multiply that whole thing by 2, what would I have to do? Like if it looked like this then. If I put a 2 times the whole thing, what would I have to do? Just distribute and then add like terms, right? That's going to give me my polynomial for the perimeter, right? Right, Otis? Is that right?
Yeah.
Getting that? Okay. So what about part 2 then? When the length is 2 meters, how could I figure out what the perimeter would be? Well, no. I'm going to have perimeter up here that's going to have a bunch of x's in it, right? It's going to have 2x cubed plus 4x squared plus some x's plus 2, right? That's my function that represents the perimeter for any value of x I choose. Well, what if it's telling me that the length is 2? Now the length is x, right? So what's that like telling me? Yeah, what am I going to plug in for x? 2. That's telling me that x is 2. So in part 1, I've got p of x equals something, right? Part 2, really all I'm doing is evaluating that at 2, right? I'm going to calculate p of 2. So plug 2 in for all the x's and just evaluate that expression and see what number I get, right? Make sense? Okay? All right.